All right, hello there, ICS3U folks. Before we get into the note on error catching, I just want to mention a few more things about the warm-up that I forgot to mention. I wanted to criticize this code a little bit, even though there's plenty of good things. There's a header and there's lots of comments explaining what's going on. There are some bad things, and we discussed in the warm-up this idea of a compound statement could be good or bad. Usually for our purposes bad, but certainly one thing that was bad about that is and hopefully you notice this right here, having a compound statement that does a calculation at the same time as the output, is not very good style. It's it's kind of the IPO, input process output, is mixed up, right? This should be processing where this is output, and that's not very good. It's not very good style. Um, and in general, there's some problems there. Problems that we can't necessarily avoid too much right now, but we will be able to soon. For instance, like, because we're reading stuff from the file, we need to do the calculations on one person and output them while we're still calculating. So we did FERD's output before we even had FERDET's input, if you know what I mean. And that's kind of bad, and we won't be able to handle that until soon, when we're talking about something called arrays. But for now, um, it's a problem. But this is not very good style. It makes our code hard to read. Another criticism I wanted to share with you is this part was good because we read from the file the number of students. Then the outside loop would run as many times as we read in the file. It would be the same code for the 2 students that we had as if there were 1,000 students. That would just change, right? Because that was read into the file. What's bad or inflexible about this code is this 4 here is no good, because this assumes that every person in that file is going to have 4 marks to read in. And as you know, some kids don't have 4 classes. Some kids have 3 classes and a spare. Some people have co-op that takes up 2 credits, and all that they would only have 3 marks. And so this is pretty inflexible. It's almost like we should have had number of courses or something like that, and then that would affect this calculation as well. And this is the idea: is we want our code to be flexible and reusable. Flexible and reusable code, and this just isn't. So I wanted to make that point before we go on to the error catching stuff. Now, the error catching, actually, before I go on to that, has got to do with this idea of, if we had trouble reading from a file, then we would just what's called throw an IO exception. Say if this file was not found, it would throw an IO exception, and Java or Ready would be left to deal with that um, in whatever way it could. And that's a problem. We don't want some small problem, some small error to crash our program. For instance, let's say there was something going on in the file where somebody in the file did only have 3 marks, and then it would read in one of the names. Ferdet is one of the marks, and tried to change that to an integer. You can't change Ferdet to an integer. It would give you an error. It would give you a number format error, and that would crash your program, and that's no good. We would like some way to recover from that, and Java allows us to do that by doing what's called catching errors. And so you've got a word processing document open, and I'm going to go through the syntax fairly quickly, and then give you an example of this in action, and then ask you to make some changes to one of your programs. So error catching. Until today, we've let Java handle all errors by throwing exceptions, right? Throw IO exception. Well, we're going to stop doing that for the most part. More often, we want to catch errors and allow a user to correct them. And believe it or not, that's the word. Throwing exceptions or catching exceptions. An exception is just a fancy Java word for an error. So here's the syntax. It's called a try catch. So try We're going to try, and then in this first block, try is a keyword. We're going to put in there the statements that might cause some sort of error. So in there would be our trying to read from a file, for instance. That might cause an error. And then we catch exception type 1, whatever, and these exception types I've tried to leave general because they can be in any order. So the exception types we've seen is file not found error, we've seen number format error, we've seen IO exception error, and then it produces the exception is actually uh, a variable type, and then we need to call it something. So ET1 is actually a variable that we produce. Like that's a variable name that we use, and it could be called, FIRD if we wanted to. This part here is something that's built into Java. This is something that we call it, and we'll see this in action soon. And then if this exception happens to occur in these statements, then these commands will be run. And so this might be code that allows the user to correct something, to fix their error. And we can have a whole list of exceptions. So exception type 2, exception type 3. We can have, if all of these things are possible errors, we could catch them all using this sort of code. And I'll show you an example soon. It says this over here, this little hint, be more specific at the start. So the more specific exceptions should be at the start of your catch code. So as we go through, and we could have a list of these exception things that are very, very long. We could have 8, 12 catch things. Our code won't do that. We'll only have 1 or 2 probably. But then at the end, we could catch any exception. So we've seen IO exception, we've seen number format exception, but even just the plain old exception throws exception. Well, that means like any old error, and we might have a catch exception that would be if you haven't found what to do with your mistake anywhere else, well then we'll do this. And again, this will hopefully become more clear once I get to the example. And then we finish off the try catch structure with a finally, and you don't have to include a finally. This could be left out if we wanted to, but then it's stuff that's executed no matter what. So let's say in this statement it threw an exception type 2. So it would run this code, and then it would skip all this other junk, and then it would run this code. And who knows what the finally would be? It could be anything. It could be closing the window, or it could be writing a file or making a file, or who knows what's in the finally part. But these commands are executed no matter what. All right. And so I'm going to get to an example. I think you should have this code that's in front of you. I'm going to make this a little bit bigger so you can see it better. Edit. Preferences, editor, make this maybe 12 or 14 so you can see it. Okay. I see that a little bit better now. And so this introduces the try and catch structure. So just quickly, let's walk through this code and see what happens. This one right here, this could cause an IO exception. So we should put that in a try catch block. Okay, so I'm gonna show you that what a try catch block looks like. So try and do this, and we'll catch it. Catch. Now I want to show you just in a second here. I'm gonna go back a second. If I were to just cut that off, that throws IO exception, and run, I want to remind you that says the method this throws the IO exception can throw the checked IO exception. So its invocation must be closed in a try statement that catches the exception, or else this method must be declared to throw the exception. And that's what we've been doing, was throw the exception. So Java is telling us you either need to put this in a try, or you need to throw it. And what we're doing today is we're not throwing it. We're gonna leave that. So this read line needs to be put in a try. And certainly I could put this statement in a try catch, because maybe there would be some problems setting up the buffered reader or the input stream reader. And notice that this is setting up a reading from the keyboard, not with the HSA console, right? This is straight from the keyboard. System.in is the keyboard. But it's this piece of code that it doesn't like. So we're going to put it right now in a try catch. Try this statement. And I'm going to catch the IOException. So that's the example of the exception we want to catch. And then we can call this anything we want to. And I'll show you how we use that. Usually we want to call it something that we can know what it means. And then in here is going to be, whatever we would like to do if this thing throws an exception. Okay. So what would we like to do? Maybe we would like to print out an error message. System out dot println. Something went wrong. Reading data from the keyboard. And by the way, this has never happened, right? We've never had this problem. We've never actually had an IO exception happen. But let's say the keyboard became unplugged or something like this. This might be what happened. And now watch what happens. Run. Oh, this is now introduced a new problem. So it's saying this variable age str may be accessed here before having definitely assigned a value. So, why wasn't this a problem before? It's saying, well, this might not occur because it's in this try. If this doesn't work and it gets caught by this exception, this might not have a value. So how can we fix it? Well, we'll go up here, and when we declared the string, we'll give it an initial value. Maybe an initial value of the null string, which is the open and close bracket. It's a string full of nothing. And now let's run it. So notice that this is going to work without us having this throws IO exception. So please enter your age. And there's some idiot proofing here, right? 1 to 100. And then it won't let me put in a number that's not between 1 and 100. Negative 3, 4, and then enter your age. So let's put in an age, and then it says thank you for cooperating. So this little while loop is almost like an idiot proofing. It's guaranteeing that you're going to get an integer between 1 and 100. And the try catch handles the IO exception. What I want to show you, and this is more important, I think, because we've been doing this idea of data casting and what happens if we want to change a string to a number and it's not a number, right? If I want to change the word furred to an integer, it doesn't work. So kind of like this. Please enter your age from 1 to 100, and I go, hello. Broke, right? It threw an error. Phone's ringing. I'm back. Telemarketer. Got rid of her in a hurry, so we're back in the lesson here. Broke, right? So I put in hello. The user has crashed my program, and I can't run it anymore. Well, notice what has happened. Java has produced this error code. It was a number format exception. So this line here, this age equals integer parse, and it tried to change the word hello into an integer and couldn't do it. So maybe I want to put that in my try statement, and I could do it in a whole separate try catch, but why don't I just do it here? I could do catch this number format exception. And then it says, well, if it if this line or one of these lines caused a number format exception to be thrown, that means maybe, and this was what happened, number format exception, system dot out dot print line, please, maybe in capitals, please enter an integer. And because this has been put into a while loop, it's going to do this. Is age less than 0 or greater? Is this, does age have a decent value? No, it does not. So that means it's going to keep doing in this while loop until it works. So I'm going to close this and try it again. Please enter your age from, so that one worked before, but if I put in hello, then it asks me please enter an integer, and it won't let me get out. Quit. Well, no, I could put in anything. I need to put in an integer. And then it says thank you for cooperating. So instead of crashing the program and having that number format exception, we caught it, gave the user a little message, and then printed it out to the screen and allowed them to fix up their input. It's a great way to ensure not only the data that's coming in from the keyboard, but also from files can work. So that's a great use of the try catch. Notice if we wanted to, we could have a finally block here. We didn't have to. Finally, and then, I don't know, whatever we would like to put in here. I'm going to put nothing. But just so you can see that what the finally thing looks like, that works. One last thing, and I know the video is getting long here, but we're almost done. The exceptions variables, one thing that you often like seeing is a little bit of detail about the error itself. And this will look familiar. So one thing that we could do is we could change this exception that was thrown, the error that was thrown, to a string and print it out to the screen. So if I put in hello, please enter an integer, and then the next line is that error message changed to a string so we could print it out. Okay, and that's what Java does kind of when we're throwing the, back up here, when we're actually throwing the exception. That's the sort of thing that it was doing. It wasn't a very useful error handling routine at all. So for instance, there might be some things that we can't, the program won't work. So for instance, if there is something went wrong reading data from the keyboard, or in some other IO exception that's problem, maybe the program has to quit. So we might put system.out.println closing, and then maybe a thread dot, just that this might not print out very nicely, but we can put system.exit, which will close the console window for us too. So I'm going to stop that and run it just to show you that it works. Notice that we're not going to get we're not going to get a system.exit. I'll put it up here too, so I can actually force that thing to occur, that error to occur, and so you'll see what system.exit looks like. I'm going to stop this and run it again. So if I put in hello, it'll print out these statements very quickly, and then it'll exit. You probably won't even see it. It'll happen so fast. Bam. Print it out, then close the window. That's what happened with system.exit. Okay. That's all I have to say about the error catching. I think you've got a short exercise to do to practice this try-catch business. But the big idea now is you shouldn't be throwing all of your exceptions. You should be catching them and allowing the user to fix the errors they're making when they're using your program. This try-catch should idiot-proof your program more. Okay, that's the goal. Okay, so you can get at your exercises, and that's it. 20-minute video. This might be the all-time new highest length video, but um, hopefully you understood it. Make sure you save your note, and if you'd like to, you can save this this code as well.